Welcome back from the ad break, and let's continue with our lesson. So now we are going to be focusing on division of polynomials, which is the next part of our lesson. So division of monomials with constant monomials. Let's look at how we are going to work with that. When we divide a monomial by a constant monomial, we divide the integers together and then we leave the variables as they are. Let's look at a few examples. We have there 12x divided by 4. So we are just going to divide the integers and the variables are going to stay as they are because we are dividing by a constant. So that is 12x divided by 4. What is 12 divided by 4? That is 3, and that variable will stay the way it is. Let's look at number 2. We have the 36p squared divided by 2. Again, just divide the integers. So 36 divided by 2, that is 18, and that variable will remain the way it is. Let's look at another example. We have 15d cubed divided by 3. So let's divide the integers. What is 15 divided by 3? Yes, it is 5. And that variable will stay the way it is. So our final answer there is 5d cubed. Let's look at 9k exponent 4 divided by 9. Do you think you know what the answer is? If you are thinking that 9 divided by 9 is 1, then you are absolutely correct. And because we are leaving the variable as it is, then our answer is going to be 1k exponent 4. Now, what about if I am dividing a monomial with a non-constant monomial? What is going to happen there? When we divide a monomial by a non-constant monomial, we divide the integers together and then we divide the variables applying exponent laws. Now, as a reminder, remember that if we are dividing powers of the same base, then we are going to subtract those exponents. So let's look at the following. We have there 20x divided by 4x. So we are going to say there 20 divided by 4, that is 5. And then we have x divided by x. Now, because we are going to subtract the exponents, remember, so that is going to be 1 minus 1, that is x exponent 0. And if we remember our exponent laws, anything to the exponent 0 is 1. And then 5 multiplied by 1 is, of course, 5. So our answer there is just 5. Let's look at the second one there. We have there 45p exponent 6 divided by 3p exponent 4. So let's start with the integers. What is 45 divided by 3? Do you have 15? Yes, you are correct. So what happened to those exponents for the variables that have the same base? Now, the 6 and the 4, we are going to subtract them. So that is going to be 6 minus 4, and our answer is going to be 15p squared as the final answer. Let's simplify the rest. So I have the 60d cubed divided by 10d squared. Now 60 divided by 10 is 6, and because these variables have the same base, we are going to subtract the exponents. So 3 minus 2, that is 1, so my final answer is going to be there 6d. The next one is 7k squared divided by 7k. So 7 divided by 7 is 1. And then we have k squared divided by k. We are going to subtract the exponents because the base is the same. 2 minus 1 is just 1. So our answer is 1k. Let's look at partial fractions. Now, for example, if I have there 12 plus 20 divided by 4. Now, 12 plus 20 we know is 32. And if we say 32 divided by 4, that is equals to 8. Now, notice how that 4 belongs to both the 20 and the 12. That's why when we added those two, they gave us 32, and the whole of 32 was divided by 4. Now, if I decide to split these into two fractions. Now, remember we started with 12 plus 20 divided by 4. If I split the 12 and the 20, they're still being added, but now each of them have this denominator. That is going to be 12 divided by 4, or 12 quarters, plus 20 quarters. Now, 12 quarters is 3, and 20 quarters is 5. And 3 plus 5 is 8. Can you see that we end up getting the same answer? What does this show? It shows that if I have a sum of two numbers and they are being divided by by one number, a constant or a non-constant monomial, that denominator belongs to both of those numbers. Let's look at it in a more practical way. So let's look at division of binomials and trinomials with constant monomials. When we divide a binomial or trinomial by a constant monomial, we divide the integers together and then we leave the variables as they are. So for example, we have here 12x plus 20x squared divided by 4. So how are we going to work with this one? Like we did in the previous example, each of these terms are going to get that exponent. So that is going to be 12x divided by 4 plus 20x squared divided by 4. And then when we divide those each individually, that is just going to give me an answer of, so 12 divided by 4 is 3, and we leave the variable as it is. And then 20 divided by 4, that is 5, and we leave the variable as it is. Let's look at a second example. So we have the 18p squared minus 70. And this is all divided by 2. So what am I going to do? I am going to split it so that they each get that divide by 2. So what is 18 divided by 2? That is 9, and that variable remains that way. And then what is 70 divided by 2? That is 35. And that is our final answer. So like we did in the previous example, each term is going to get the denominator. What about when we are working with a trinomial? The same thing would apply. This denominator belongs to each of them. So this means that we are going to say 2x squared divided by 2 minus 8x divided by 2 plus 50 divided by 2. So the final answer there is going to be x squared minus 4x plus 25. And that came from us dividing. Let's look at this one. That there is a negative 9p cubed plus 36p plus 30, and that is all divided by 3. Now that is going to be a negative 9p cubed divided by 3 plus 36p divided by 3 plus a 30 divided by 3. What is going to be the final answer there? Negative 9 divided by 3 is a negative 3p cubed plus 36 divided by 3, that is 12p, and a 30 divided by 3 is a 10. Let's end off the lesson with division of binomials and trinomials with a non-constant monomial. So when we divide a binomial or trinomial by a non-constant monomial, we divide the integers together and then we divide the variables and apply exponent laws. Again, as a reminder, because we are dividing powers of the same base, then we are going to subtract those exponents. For example, we have the 12t exponent 4 plus 16t all divided by 2t squared. Again, we are going to separate them so that that denominator belongs to each term in the numerator. And that is going to give us, when we simplify it, what is 12 divided by 2? That is 6. And now we have t exponent 4 divided by t exponent 2. Same base, subtract the exponents. 4 minus 2 is 2. So that gives us an answer of 6t squared. And then the next term there is going to be 16 divided by 2. That is 8. And then now we have t exponent 1 divided by t exponent 2. Again, same base, so we subtract the exponents. So that is going to give us 1 minus 2, which gives us t exponent negative 1. Now what you need to take note of here is that our answer here is not a binomial. So yes, it has two terms there, but because the second term has a negative exponent, then that is not a polynomial. It does not fall under polynomials. So we cannot call that a binomial. And also remember that when we are working with exponents, we do not leave our answer as a negative exponent. So if you remember your exponent laws, how can we fix that second term so that that exponent is positive? So we are going to have here 6t squared plus 8, and now that variable t is going to become a denominator, and that exponent 1 is now a positive exponent instead of a negative exponent, and that is our final answer. Let's move on to the second one, where we are working with a trinomial that is being divided by a non-constant monomial. So same thing will apply. We are going to separate them. So that is 6d cubed divided by 3d squared minus 21d squared divided by 3d squared plus 3d divided by 3d squared, because that denominator is for all of them. So now we are going to divide. What is 6 divided by 3? That is 2, and we are going to subtract the exponents since the base is the same. So 3 minus 2, that is 1. Minus, then we are going to say 21 divided by 3, that is 7. And again, the exponents are going to subtract because we are dividing powers of the same base. That is 2 minus 2, that is going to give us a 0. And we are going to add 3 divided by 3 is 1. Then we have a d exponent 1 divided by a d exponent 2. That is going to say 1 minus 2, and that is going to give us an answer of d exponent negative 1. But again, we cannot leave our exponent as negative, and we also cannot leave the d exponent 0, because according to our exponent laws, we should know what that is equals to. So anything to the exponent 0 is 1. So that means our 7 remains that way, as it is going to be 7 multiplied by 1, which is 7. And again, to avoid the negative exponent, we are just going to turn it into a fraction, making that exponent positive. That is it for today's lesson. I really hope you did enjoy it as much as I did. We hope to see you next time. Goodbye.